Okay. Good afternoon. Okay. In last lesson, we have started about electrostatics, which is the study of electric charge at rest. And a body can be neutral or it can be electrically charged. The body has two probabilities. It can be neutral or it can be electrically charged. When you say a body is neutral, even we can start from atom. As you know, the building block of all materials or matters is atom, and an atom is said to be neutral at normal condition. If an atom is at a normal condition, it's neutral. But it doesn't mean that an atom doesn't possess an electrical charge, or since the number of electron and the number of proton is equal, then an atom under normal condition is said to be neutral. Even though it possesses a sort of charges, is said to be neutral because the two charges equal in magnitude but opposite in sign, then they will cancel to each other. And as a result, an atom remains being neutral. But an atom can be electrically charged if it is an ion. And an atom will be ion when it loses an electron or when it gains an extra electron. Then when the number of electron and the number of proton in a given atom is not equal, then an atom is said to be electrically charged or ion. It is changed into ion. And in a similar fashion, a body can be electrically charged when there is an equal number of proton and electron on its surface. For example, if the number of electron which is found on the surface of a metal or a material exceeds the number of proton, then the body is negatively charged since it possesses more electrons. And the other possibility is if a body is with a deficiency of electron, then the body is said to be positively charged because the number of proton exceeds the number of electron. If electron is surplus on a given material, then the body is said to be negatively charged. And in a similar way, if the number of proton is surplus, then the body is said to be positively charged. And the other one, there are law of electrostatic. We said that a body can be electrically charged. If a body is electrically charged, then it can be, it has two probabilities. It can be positive or it can be negative. Then there are two types of charges: a negative charge and a positive charge. A negative charge is happened when an excess of electron is on the surface of a material, and a positive charge can be happen when a surplus of proton is on a given material. Then there are two types of charges, which is negative charge and positive charge. And there is an interaction between these two types of charges. And this results law of electrostatic. And the law of electrostatic states that like charges repel each other and unlike charges attract to each other. This is said to be law of electrostatic. There is interaction between charged bodies. For example, if we are looking only if we have only two bodies with the same charge, then there will be a repulsive force. And if you have two bodies with an opposite charge, then there will be an attraction force between them. Then the interaction between the same charges is repulsive, and the interaction between an opposite charges is attractive. Then there are two probabilities. For example, if we are with two objects or bodies with a certain mass having an opposite charge. For example, this body, it may be body A, and this one is body B, and the charge on the surface of body A is positive, and the charge on the surface of body B is negative. Then they have an opposite charge, they carry opposite charge. The two bodies carry an opposite charge. If they carry opposite charge, we know that there is an interaction between the two bodies. And on their surface, this B is with negative charge, and A is with a positive charge. The net charge on the surface of B is negative, and the net charge on the surface of B is positive. Then there is an interaction. What kind of interaction will happen on these two bodies?
Like charge repels each other, and unlike charge will attract each other. So both of them will attract each other.
Yes, they will attract to each other because they possess an opposite charge. There should be interaction between A and B. It's obvious that there is an interaction between A and B. And the interaction can be repulsive or it can be attractive, but according to law of electrostatics, there should be an attractive force. Then A will attract body B, and body B will attract body A, and finally they will be close to each other. There will be an attraction between them. There is a force, there is an electric force, and this electric force is attractive force. If they have a small mass, then they will bring at a certain point, or they will be close to each other. It's possible, even it's possible to demonstrate in laboratory. And the other one, they may have the same charge. For example, this body A is with positive, and B also with positive charge. If the net force on body A and B, both of them carry the same charge, which is positive charge. Or it's possible that the two bodies may have a negative charge. The other possibility is body B and body A may have the same charge. When we say the same charge, it can be both positive or both negative. Then what kind of interaction will take place in the first case? For example, let's be this is case A and case B. The two bodies has carried or have carried the same charge. So what will be the interaction between these two bodies? Since they carry the same charge, there will be a repulsive force. So they will move away from each other. There is a repulsive force between two positively charged bodies, and in similar way, there is a repulsive force between the two negatively charged particles, or it can be a big body, or it can be just a particle. Then we can generalize this concept as like charges repel each other and unlike charges attract to each other. There is an attraction force between unlike charges, and there is a repulsive force between like charges. And this event or phenomena is called law of electrostatic. It's always true that there is a repulsive force between like charges and attractive force between unlike charges. And the other one, a law of conservation of charges. Just like that of law of conservation of mass, there is law of conservation of charges. In law of conservation of mass, as you know, mass of the system remains constant, but there may be some change in form of mass or phase of mass. And similarly, in electric charge cannot be created or cannot be destroyed. It only can transfer from one atom to another atom, or it transfer from one body to another body. When a body is charged, doesn't mean that we have created a charge, but due to the transfer of electrons, then the body can be charged. But the amount of charge of the system remains the same, despite the amount of charge, despite the amount of charges in a given body, but the system charge will remains constant. But there will be transfer of electrons or transfer of charge from body A to body B, but doesn't mean that we have created a charge or we are created an electron. What happened is only the transfer of electrons from one body to another body. Due to this transfer of electron, charge will produced. So this is said to be conservation of charges, and it states that the total electric charge of the system remains constant despite charges inside the system. There may be a charge that transfers from one body to another body, but the amount of charge in a given system, if our system is isolated system, no charge will leak. So the amount of charge in a given system remains the same. And the other point that we need to discuss today is the charging mechanism. We do have a process of charging. We can make a body to be charged, or we can discharge the body. Therefore, there are some mechanisms. Especially the common one are three mechanisms. And when we say charging mechanism, it's the process of producing charge, not creating, but producing charge on a neutral body. If we need a body to be charged, we can have some mechanisms just to make a body charged. And the most common methods of charging are rubbing, conduction, and induction. We can just electrically charge a body by using rubbing or by using conduction. And the other possibility is by using induction method. Let's see each of them step by step. First one is charging by rubbing. The other name of charging by rubbing is friction, charging by friction, because one body needs to rub to against the other body. A body needs to rub against the other body. And for this case, just a neutral body to be charged, first we need to have two bodies. There may be neutral bodies or charged body, but we have to have two bodies. And these two bodies need to rub to each other. There should be some sort of friction. For example, if we are taking a silk cloth and maybe a plastic rod, we do have two bodies, which is rod and the cloth, and then the rod need to rub against the silk. Due to this process, there will be a transfer of electrons between these two bodies, and electrons transfer from one body to another body. Assume we have two bodies first, body A and body B. if these two bodies are in friction one against the other, then there will be the exchange of electron from body A to body B. Assume electrons are transferred from body A to body B based on their electronegativity. Electron will transfer from one body to another body. Assume electrons are transferring from body A to body B. Then body A will be with a deficiency of electron, and body B becomes with surplus of electron. Then due to the loss of electron or some amount of electron has been transferred from A to B, then body B becomes positive. Body A becomes positive, and the one who accepted electron becomes negative. So we have resulted with two different charges. Body A becomes positively charged, whereas body B becomes negatively charged. And this process is called charging by rubbing or charging by friction. So we have to have two bodies, and the two bodies need to rub to each other. And when they are in a sort of friction, then electrons will transfer from one body to another body. And due to this transfer of electron, the one that accepts electron becomes negative, and the other one that loses electron becomes positive. So we have produced positive and negative charges, which means two different charges. Finally, the two bodies has been possessed or carried two opposite charges. And the second charging mechanism is charging by conduction. This is applicable for a conductor, and there is sharing of electrons or sharing of charges. For this case, we have to assume about a charged body. First, we have to have a charged body. One object or one body or one material need to be charged. For example, it may be negatively charged. Assume this is body A, which is negatively charged. And the other one that needs to be charged is a neutral object, for example. But this should be conductor, which is a neutral conductor. Assume this is body B is a neutral conductor. And they need to be in a physical contact. They have to touch it to each other. They have to be in touch to each other. Or the body A needs to be in a physical contact with body A. Then when they are in a physical contact, charges will transfer from one body to another body. Assume A is negatively charged. Since A is with excess of electron, then electron will transfer, or negative charge will transfer from body A to body B. Due to this transfer of negative charges, then finally we obtained negatively charged body B. Then finally they will have the same sign. Two bodies will be negatively charged. So finally, this process has been resulted with two charged bodies of the same sign. They have the same types of charges. So for this conduction process, one body needs to be charged and the other body can be neutral. And then the two bodies have to bring to each other just to be in a physical contact or in touch to each other. Then after being in a physical contact, there will be exchange of electron or charge. Charges will flow from excess region to less or deficient region or scarce region. Then after transferring charges or flowing charges, then finally they will be the same sign. With the same sign, they will carry a charge that have the same sign. And the third method or mechanism is charging by induction. This charging by induction. And this charging by induction also happen first. There should be a charged body, electrically charged body. It can be electroscope or it can be any charged body, but it should be a charged body. And these charged bodies can be bring near to the neutral conductor. For example, this method helps us just to charge a sphere, for example. Assume we do have spherical conductor. This is a conductor, and this conductor need to put on an isolated. This is insulating material. And this one is conducting sphere. Conducting sphere or metal sphere. It should be a metal sphere. Then initially the sphere is neutral, which puts on insulating objects. It should place on insulating object. And the mechanism is we need to bring a charged object, for example. This is maybe charged rod. It may be negatively charged or positively charged rod. Let it be positively charged rod. We have brought a rod which is positively charged, which is charged in another place and has been brought near to the neutral sphere. Then what happened? But we don't need to touch to each other or to be in a physical contact with each other. We have to approach it without a physical contact. We have to approach it. The rod is near to the sphere, but not in a physical contact. And what will happen on the charge which is found on the sphere of a conductor? There are an excess of delocalized electron on the surface of a sphere. Then by the nearby charges, they will get a disturbance. And due to this disturbance, for example, electrons on the left side of this sphere will migrate to the right side of the sphere by leaving a positive charge to the left. And it becomes the separation of charges will happen. Assume there will be a positive charge to the left side and a negative charge, more negative charges on the right side. So the sphere becomes a dipole, slightly positive and slightly negative due to the nearby charge. Because there is a repulsive force between positive charge and negative charge, then electron that carries negative charge will migrate to the right side by leaving a positive charge to the left side. Then now the charge has been separated, positive and negative charges has been separated, and to the right side there will be more accumulation of negative charges. And then there are mechanisms which is called grounding. Let's bring a wire and connect with sphere and touch into the ground. This mechanism is sometimes called earthing, grounding or earthing. This is a wire, a conducting wire. This mechanism is called grounding. Just by grounding, we let electrons to flow to the ground. For example, we have used a conducting wire to the right side of a sphere, and when they becomes just in contact with a wire, electrons will flow down to the ground. Electrons will flow down to the ground. And finally, the sphere left with a positive charge only. Just after grounding, we need to bring or withdraw the positive charge, and we left the sphere alone. And due to the withdrawal of this positive charge rod, the charge on the sphere will redistribute. There will be a redistribution of charges. Due to this redistribution of charges, we know that if an object is a regular object, charge will distribute evenly. There will be a uniform distribution of charges. Initially, there will be more charges on a left side. Then after the positive charge rod has been withdrawn, charge will redistribute. And after evenly redistributed, the sphere becomes positive charge. Positive charge. Finally, we have produced a positively charged sphere. This is one of the mechanisms of producing a charge. Then to summarize, charging by induction, it needs first two bodies. One is positively charged and the other, it can be neutral because it's subjected for charging. And we have to bring a positively charged rod near to the sphere, but the sphere needs to be put on insulating object just to avoid the leaking of charges to the ground. And the electrons on the sphere will influence it by the nearby charges. There is a nearby charge positive rod, and the nearby charge will influence charges on the surface of a sphere, and there will be a separation of charges. Separation of charges will happen, and due to this separation of charges, we can ground it. After earthing or grounding, then the charge finally redistributes, and we're left with a positive charge. So these are the three mechanisms for charging. And to summarize, we can produce charges. A neutral object can be charged. Even the charged body can be discharged, or we can change into a neutral. A neutral body can be changed into charged body, and the charged body can be changed into a neutral body. Two of them are possible. So to produce charge, there are common mechanisms. The first one is charging by rubbing. The second one is charging by conduction. And the other one is charging by induction. These are the most common mechanisms that we use to produce charge. A neutral body can be charged by these mechanisms. The first mechanism is charging by rubbing, which is charging by friction. Due to friction, electrons will jump from one body to another body. Due to the transfer of electrons, then the one that gains electrons becomes negative, and the other one that lost the electron becomes a positive charge. So it's possible to produce two opposite charges at the same time by interchanging or by exchanging electrons between the two bodies. It's possible to produce two opposite charges at the same time. And the second mechanism is charging by conduction. And charging by conduction, just to be happen, we need first a charged body. One needs to be charged, and the other one, it can be neutral. Then when the charged body is in a physical contact with the neutral one, there will be electron transfer or charge transfer among these two bodies or between these two bodies. The one that has a charge will give charges to the neutral body, or charges will flow from charged body to a neutral body. And due to this exchange of electron or exchange of charges, then the two bodies finally will have the same charge, the same types of charge, because they have shared the same types of charge. It can be positive or it can be negative, but finally they will have the same types of charge because they have shared the same types of charge. For example, for this case, A is initially charged object, whereas B was neutral. Since A is with an excess of electron has been migrated from A to B, and after has been redistributed, finally the two bodies will have the same types of charge. And the final mechanism of charging is charging by induction. And for this case also, we have two objects. One is initially charged, but the other one is a material that is subjected for charging. And just to use this mechanism, to use this induction mechanism, we have to put the conduction material into insulating material. This is very important point. Unless electron will leak to the ground, unless it is placed on insulating object. Therefore, the one which is subjected for charging needs to be conductor. Since it is conductor, it needs to put on insulating object. Then let's bring a charged object. It may be positive or it can be negative, but initially charged object. Assume we have brought a positively charged rod. When the rod approaches the sphere, then charges on the surface of the sphere has been disturbed, and due to this disturbing by the nearby charges, the charges that have an opposite sign with the rod has been migrated to the right side. For example, the rod is positive, then electrons will attract, electrons will be attracted toward the positive charged rod, and after grounding, then the charge will be redistributed. As you know, Earth is a good acceptor of electron and a good donor of electron. Earth doesn't have a scarcity of electrons. And the other one is less much these terms. The first one is charging by friction, second one is charging by sharing, and the third one is charging by induction. And as an alternative, A says the two bodies finally carry the same types of charge. B, the two bodies do not touch to each other. There is no physical contact between the two bodies. And C, the two bodies must travel to each other. They need to be in a friction one against the other. Then how can we match it? Let me give you time just to do this.
Number one.
Okay, for charging by friction.
C.
C.
It's C. Charging by friction, of course, yes, it's C. See, because in friction, the two bodies need to rub to each other. Of course, yes. And for charging by sharing,
B.
yes.
B.
B.
A.
A. The two bodies finally carry the same types of charge. Of course, yes. Because they have shared the same types of charge. So sharing is just since they share the same types of charge, it should be A. And finally, it becomes
B.
B. Charging by induction doesn't need a physical contact. The two bodies never been in a physical contact, but when we bring near to each other, then the one which is neutral will be influenced by the charged body. Do you have any question? Do you have any question?
No.
Okay, thank you very much. Okay.